Next up on Kitchen Chemistry, we're going to look at Boyle's Law. As you guys might know, I love scuba diving. Check out my other videos. And Boyle's Law is super important when you're scuba diving because it relates the volume of a gas to the pressure that you're under. And as you go deeper and deeper underwater, you're under more and more pressure. So in a minute, we're going to take a look at how that affects gas and why that needs to be something you pay attention to when you're scuba diving. So in this bottle, I have what's called a Cartesian diver, and it's a glass tube that's filled with air, and then I have it inside a water bottle. And as I squeeze this water bottle, I'm increasing the pressure. As I squeeze it more and more, you notice the Cartesian diver dives to the bottom of the bottle. And then as I release pressure, it comes back up to the top. Increase pressure. Do you notice anything that happens as I increased the pressure? And release pressure. Increase pressure, decrease pressure. Increase pressure, decrease pressure. So we're looking at the increase in pressure and the change in volume of the gas that's inside the Cartesian diver. As that gas is compressed, it becomes more dense, causing the Cartesian diver to dive. This relates to scuba diving because as you go underwater, your body and the gases that you're breathing are under pressure. And as you come up, they're going to expand. So when you're at depth, you're getting things like nitrogen, oxygen. All those gases are dissolved in your bloodstream in teeny tiny bubbles. And as you come up, if you come up too quickly, those bubbles can expand to a size that doesn't fit through your veins and arteries and capillaries, and they can cause a blockage, not allowing blood to continue flowing through those places, which basically causes a stroke. It's called an air embolism. So it can cause a stroke, it can cause blood to not reach other extremities, and if you have that problem, you immediately need to go to a decompression chamber where they're going to put you back under pressure, and then slowly and controlled in that chamber, they're going to release the pressure over a period of many hours, causing those bubbles to compress and then diffuse through your body so that those bubbles are not as large when you come back up to regular pressure. Here we have a second example of Boyle's Law where I've put some water in a vacuum chamber and I've sucked all the air out, creating a vacuum, meaning there's no pressure. And because there's no pressure, we know according to Boyle's Law that the volume is going to increase, meaning that this liquid is going to start turning into a gas, i.e. it's going to start boiling. So you can watch this video and see this liquid begin to boil. You'll also notice, if you were here to feel it when we took it out of the vacuum chamber, that it's nice and cool because as you release pressure, we know that according to Charles's law, temperature is going to decrease. So you can see a little bit of Charles's law in this experiment as well.